Starship 13 flies and lands softly in the ocean. Astronomers see the companion star for Betelgeuse. A comet spun down, reverse direction, and might tear itself apart. Did Webb see primordial little red dots? And on Space Bites Plus, measuring the heat working its way out of Io. All this and more in this week's Space Bites. First up, let's talk about last week's Starship launch, which happened right after we recorded and released our episode last week. This was the 13th flight of Starship. The plan was to launch the Super Heavy booster, detach Starship. Starship would deploy some Starlink satellites, and then it would return and land softly in the Indian Ocean. So how did it go? Well, Super Heavy and Starship launched successfully from the Starbase Texas, and then a few minutes into flight, Starship detached from the top of Super Heavy, and Super Heavy turned back to make its landing burn. Now, they were not planning on catching this version of the booster, and good thing, because not all of the engines relit when it was on its way down to its landing in the ocean. And if you were watching the video, it came in pretty hard. So good thing they didn't have it try to get caught by Mechazilla. So clearly there were still some bugs to be worked out in the V3 Raptor engines as part of the new Super Heavy booster. And then Starship lit its engines and made its way up to space. It deployed 20 V3 Starlink satellites. And this was the first time that they had actually deployed these operational satellites. Of course, they were following Starship on the same ballistic trajectory. And so they burned up in the atmosphere shortly after Starship began its maneuvers back into the atmosphere. And this was the coolest part of the entire mission, in my opinion. It made its way down to the Indian Ocean, as all of the previous flights that have made it this far have done. And then it made its retro firing burn and made this extremely soft landing in the ocean. So soft that you got these images of drones flying overhead that you could see that it did not explode when it hit the ocean, which is what it had done all the time in the past, and then sunk down into the ocean. This time, it was just sitting there, floating. And in fact, it's kind of surprising how seaworthy Starship is, but I guess it's got ship right there in the name. And apparently it had been floating for days and days. And we got a tweet from Elon Musk saying that, in fact, they were sending a boat out to try and capture Starship and bring it home. And that would be great, because now they would get a chance to be able to analyze what was the damage to the heat shield, how did all the various components inside the rocket fare for the entire mission. According to Musk, SpaceX landed so softly that it could have been caught by Mechazilla. And so maybe this is what they need to be able to now have the Starships land at Boca Chica like the Super Heavy boosters do. And in fact, Elon Musk said next time they're going to try and catch Starship. So this is progress, we hope. And so with this test out of the way, SpaceX still has many more tests that they have to do in preparation for the upcoming Artemis 3 launch. This is where an Orion capsule on top of a space launch system is going to try to dock with either SpaceX Starship or the Blue Origin Blue Moon lander, or both, depending on who's ready at the time. And there are a lot of tasks that still need to be completed before the human landing system version of the SpaceX Starship is ready to go. So another test out of the way. I'm sure there will be more tests coming up as SpaceX tries to fulfill their obligations for the upcoming Artemis missions. And our coverage of the Starship 13 launch was written by Alan Boyle on Universe Today. We've been reporting on the possibility that Betelgeuse has a companion star, which would explain a long-standing mystery about this star. So Betelgeuse is a dying red supergiant star. It's right at the very end of its life, and it has this variability that is caused by just the standard fluctuations that these supergiant stars go through. They are changing in their size, they are puffing out globs of dust that can obscure the star from our perspective, but there was this secondary oscillation in its brightness that lasted for thousands of days that astronomers have had a hard time explaining. The leading theory is that this was caused by a companion star. And so sometimes you were seeing the combined light of both Betelgeuse and its star. Other times you were seeing Betelgeuse, but it is blocking its companion star. And about a year ago, astronomers announced that they had detected this brightness on one side of Betelgeuse that they attributed to this companion star. But they knew in December 2024, whatever this object is, it would be at its greatest distance from the limb of Betelgeuse. And so they used one of the most powerful telescopes on Earth, the European Southern Observatory's Very Large Telescope. And specifically, they used the Sphere instrument, which is good for finding exoplanets around stars. But in this case, they were able to resolve the companion star orbiting around Betelgeuse. So this is Betelgeuse B, and it's actually a little larger than astronomers thought. They believed it was about the mass and the size of the sun, but new evidence shows that it's actually 2 to 3 times more massive than the sun. So it'll be interesting to know how this star will interact with Betelgeuse in the future. It is so close to the surface of Betelgeuse that it is interacting with the atmosphere of this star, and that additional turbulence and mayhem. Like, imagine if it actually got pulled into Betelgeuse. That would be something. And then a couple of weeks ago, we reported that NASA had sent a mission to try to recover the Swift Space Telescope. The problem is that Swift has been operating successfully for so long that its orbit has been slowly declining to the point now where the drag from the atmosphere is going to start building exponentially, and it will have a much shorter lifespan. And so NASA contracted with a company called Catalyst to build the Link servicing spacecraft. This spacecraft was designed to fly up to dock with Swift and then provide a thrust that would be able to raise its orbit back up so that it would then be years, maybe even decades, before its orbit would lower again. But we've learned that after the successful launch of the spacecraft, it is now tumbling wildly. And the reason is, say it with me, failed reaction wheels. So 2 of the reaction wheels on the Link spacecraft have failed. And so now it is tumbling out of control. The mission controllers think that they might be able to get it back under control using the ion engines on board the spacecraft. And if they can, then they will try to continue with the mission. Because really, all they've got to be able to do is dock with Swift and then provide enough of a kick to raise the spacecraft to this higher orbit. The good news is that even though it is tumbling, it's still getting enough power into its solar panels that it can continue its operations. And this is sometimes what kills tumbling spacecraft, is that they're designed to stay in this stable position, point their solar panels at the sun, get all the electricity. When they're tumbling, then the solar panels are half on, half off. But fortunately, they've got enough energy to still be able to do what they need. So it's in orbit, it's out of control, but maybe they can get it back into control and maybe they can still finish the mission. I'll keep you posted. Back in the olden days, NASA was planning to launch a successor to the International Space Station that was going to go to the moon. And this was going to be called the Deep Space Gateway, or the Lunar Gateway. And this would be flying in a very special orbit, a halo orbit that kept it in a perfect balance between the Earth and the moon. And this would serve as a stepping stone between Earth and missions to the moon, where you would fly to the lunar station, then you would transfer to a lander and go down to the surface of the moon, back up from the moon to the gateway, and then come back to Earth. And to test out this novel orbit, NASA sent a mission in 2022 called Capstone. That stands for the Cislunar Autonomous Positioning System Technology Operation and Navigation Experiment. It ran successfully until about a month ago, proving this orbit was going to be stable, and now NASA had a lot of information to launch the Lunar Gateway, which is now probably not going to happen. But NASA has announced a second Capstone mission that is going to the moon. And this one, called Capstone 2, is going to test out various autonomous fleet navigation. So they're sending 2 500-kilogram spacecraft that are then going to play in lunar orbit. They will take turns chasing each other, getting closer, farther away, and see what the 3-body interactions between the Earth, the moon, and these 2 spacecraft will cause. And then that will give a lot better information for all of the upcoming docking and various rendezvous and maneuvers they're going to need to happen with all of these spacecraft that are going to the moon. So the plan is to launch Capstone in 2027, and then I'm sure it will last for several years with these 2 spacecraft just playing in lunar orbit. Next up, we've got a couple of stories from China's Chang'e-6 lunar sample mission. Now, if you recall, a couple of years ago, China sent a mission to the far side of the moon and retrieved samples from the first time. This was Chang'e-6. They brought about 1.9 kilograms of rocks back to Earth. And in those samples, they have made a couple of really interesting discoveries about the history of the moon. First up, they discovered something really interesting about the solar wind and how it interacts with the moon. The solar wind are these constantly streaming high energy particles coming from the sun. And they strike the Earth and the moon, and there is the near side of the moon and there is the far side of the moon, and it doesn't really matter. Both sides are going to be hit by the solar wind. But by analyzing the samples from Chang'e-6, the scientists realized that in fact, the speed of the particles hitting the moon change depending on which side they're hitting. So they hit faster on the far side of the moon than they do on the near side of the moon. So why the difference? Well, it turns out it's the Earth's magnetosphere. There is this giant magnetic field around the Earth that really protects us from those high energy particles, as well as the galactic cosmic rays. And the magnetosphere forms this comet-like tail that is pointing away from the sun. And when the moon passes where the near side of the moon is facing the sun, it is also in the tail of the Earth's magnetic field, and so it's protected from the fast-moving particles coming from the sun. And so they're able to look at the kinds of particles that were embedded into the regolith on the far side of the moon, such as helium, neon, argon, krypton, xenon, and radon, and then compare the isotopes that they find there as well as the ones they find from the near side of the moon from other samples, and found this difference. So that's kind of cool. The second thing they looked at was the rocks that were formed during the late heavy bombardment in the solar system. And this was a time when the planets in the solar system were migrating around, and this caused a lot of chaos, and there were a lot of asteroids raining down on various bodies in the solar system. Almost certainly the Earth, but definitely the moon. Now, the bombardments on the Earth are lost because of the very dynamic geologic activity. We have plate tectonics, which hides the scars from the craters that hit us a long time ago. But the moon never had plate tectonics, and so it has remembered everything that's ever hit it. And so scientists analyzed the samples from Chang'e-6 and were able to determine the rate that the late heavy bombardment was happening on the moon, and found that in fact it didn't end as quickly as astronomers had originally predicted. It actually had this much more gradual decline at the end, and so the late heavy bombardment lasted longer, and there was still damage happening a lot longer after astronomers originally thought. And both of these stories were written by Matt Williams. Now I've got a story about a comet that spun down, reversed, and spun back up again. This story is covered by Lawrence Tugnetti, who has a master's in planetary science. The official name of the comet is 41P Tuttle Gaiocabini Crescec, but we just call it 41P. And in 2017, 41P made its perihelion with the sun. That's the closest point of its orbit. And this is when a lot of the mayhem happens on comets. Astronomers are watching it with the Hubble Space Telescope, and what they saw was the comet slow down its rotation rate, stopped its spin, and then started to spin back up, but in the opposite direction. And what astronomers think happened is that there are jets coming off of the comet, and that these were so unbalanced that they acted like thrusters that slowed down the rotation rate of the comet, stopped it, and then spun it back up again in the opposite direction. And that this spin up could continue with future perihelions, and this could cause the comet to spin itself up to the point that it tears itself apart. And this is a limit that we see with rubble pile asteroids and probably comets as well, which is that there is an upper limit to how quickly these things can spin before they just tear themselves apart. If you find an object that's spinning more quickly, then it has to be a single solid object, like one rock or a chunk of metal or an alien spaceship. I shouldn't even say that. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was that the Milky Way flipped its disk. So thank you everyone who took the time to vote last week. Of course, by the time you're watching this video, the new vote is in the post tab here on our YouTube channel. So go ahead and vote. Of course, the best chance to see this, click on subscribe, click on the notifications bell, and then like this video. And in fact, I want you to do me a favor, and that is, can we get this video to 5,000 likes? You should see the number of likes on this video right now. If that number is less than 5,000, click like. And then maybe the algorithm will smile upon us and show our videos to more people. Next up, we've got a couple of stories about little red dots, which I am currently obsessed with. So the first story comes from Carolyn Collins Peterson, and this is that James Webb appears to have seen a primordial little red dot. Now, I've talked a lot about little red dots, but here's the short version. These are strange reddish objects that are extremely compact, probably just in the tens of light years across, seen only early on in the universe, and then we don't see them later on. It's believed they are probably a supermassive black hole of some variety covered in some amount of dust, but it is still a mystery, and there's a lot of problems that theory doesn't resolve. So astronomers announced that they had seen a little red dot with James Webb, and in this case, it was seen more magnified than it normally would be thanks to a gravitational lens. It was seen inside a starburst galaxy that is probably within the first 10 million years of its life. It's metal poor because it just hasn't had time to go through the generations of stars to build up the metals, but it is forming stars at a furious rate, and it has the evidence of a little red dot at the center of it. So maybe that's a clue. The second story comes from Evan Goff, and this is the theory that little red dots are globular star clusters. And when you think about globular clusters and little red dots, there's actually a lot in common. Both are in the tens of light years across range. Globular clusters are as old as the universe itself, which means that they probably had some earlier version of what they looked like. So there's a paper that came out that proposes that little red dots are what globular clusters looked like at the very beginning of the universe. And that would be very different from what globular clusters look like today. Today, they are filled with old stars, as I said, as old as the universe itself. All of the big bright stars went supernova a long time ago. In this paper, the astronomers propose that there is in fact a supermassive star located inside these globular clusters, and that would be responsible for giving off a lot of this reddish light, red supergiant star. That star went supernova, seeded the globular cluster with heavier elements, and we got further on cycles, but this would explain what we see today. Now, this is a very kind of out there theory, and there isn't a lot of observational evidence that says that this is the case, but one really interesting correlation is if you count up the number of globular clusters that there should be in the universe and compare that to the number of little red dots that James Webb is finding, the numbers are kind of within an order of magnitude of each other. So they are kind of roughly similar, which could mean that for every little red dot that we see, there maybe later on would be a globular star cluster. Now, this is a really interesting idea. I love globular clusters. I love little red dots. And I actually interviewed Dr. John Chisholm a couple of months ago when the first pre-press version of this paper came out. And so I kind of got to this story 3 months ago. And so if you want to go and see more information about this idea, we'll put a link to the interview in the show notes. But I also did an interview a couple of weeks ago with Dr. Vasily Kokorev, and he sort of helped me understand just how much uncertainty there is in the astronomical community about little red dots. And that interview was just fantastic. So links to both of those interviews are going to be down in the show notes. Astronomers are still hoping to find that first exomoon, and although this doesn't quite qualify, hopefully this will keep everybody happy for a little while. So we've got a story from Dr. Brian Koberlein about a pseudo-exomoon. So the system is called CD352722. It's an M-dwarf star that is 70 light years away. And astronomers detected the presence of a brown dwarf in the star. So that is a failed star. It's not big enough, massive enough to ignite hydrogen fusion in its core, but it is massive enough to have deuterium fusion in its core. It's about, say, 29 to 38 times the mass of Jupiter. Astronomers were watching the motion of this companion brown dwarf to the red dwarf, which is a surprising binary system when you think of it. And they noticed a slight wobble around this brown dwarf. And they were able to determine that there is a Jupiter mass, Jupiter-sized object in orbit around the brown dwarf, which is in orbit around the red dwarf. Is that an exomoon? Probably not. We're going to have to let the International Astronomical Union argue over about that and maybe, make Pluto a planet again. But it is an exciting object nonetheless. And I think I saw Dr. David Kipping had done a video or a short about this as well. I hope you're enjoying this week's episode of Space Bites. Of course, you probably had to see some advertisements when you watch this episode. We can't control the ads that YouTube wants to show you, but we think that there is a better experience over on Patreon where you can watch it ad-free, completely for free. And to encourage you to go over and watch this episode on Patreon, we've released the exact same video, but with one extra story. And this week's bonus story is how NASA's Juno mission was able to use some instruments to measure under the surface of Io in a way that was never expected. And I'll put a link in the show notes to that episode. And of course, this is just a fraction of the space news that we're covering on Universe Today. We typically report on 30 to 50 space stories every week, and we can only cover just a few of them here. So if you want to stay on top of all of the news, of course, you can just go to Universe Today and reload the homepage every couple of minutes, or you can sign up for my weekly email newsletter, which I send out on Fridays. I write every word. It contains a summary of every single story that we're covering on Universe Today. It's completely free. You can sign up, go to universetoday.com/newsletter. I'm going to talk about how this is the most exciting time of the year. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bailock, Dark Finga, David Gilton, and David Matz, Enthraled Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Madden, Jim Burke, Marcel Smits, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Rankaidu, Richard Williams, Sean Sargent, Stephen Filer Munley, Team 49, Telescopes Canada, Vlad Shiplin, Wolfgang Klotz, Zelda. Oh my God, we have proof of aliens. That's the one you're going with, Zelda. We're permanent now. And all our patrons. Your support means the universe to us. So I mentioned that this is the most exciting time of the year, and that is because we are now doing the NIAC Award interviews. And NIAC is NASA's Innovative Advanced Concepts. This is where they reach out to researchers around the world to send in their best sci-fi ideas. Only the ideas that are extreme, that test really crazy concepts, that push the technology to the limits, that imagine way outside of the box, are accepted. And then they give seed funding for people to develop their ideas. If the ideas go somewhere, then they'll give them a phase 2 funding and a phase 3 funding, and then they graduate. And so every year NASA announces the winners of all the different phases. And about a week ago, we got an announcement of the 2026 phase 1 winners. And that is my cue to send out an email to every team that won a NIAC award and try to get them here on the channel to do an interview. And my success rate is very high. So I've already probably lined up about a third of the people who have won NASA NIAC grants this year. I've already interviewed one and we've released it out here on the channel. The time you're watching this, I am probably recording 2 more. And so over the next month and a half or so, you should expect to see as many NIAC Award interviews as I can possibly get. This first one is a banger. This is an idea to put 2 spacecraft about 15 million kilometers apart in the same orbit as the Earth, one ahead of the Earth, one behind the Earth, and both will be giant radio telescopes, and they will act as an interferometer to observe the event horizon of the biggest known black hole in the universe, TON 618. And so if the idea of an interferometer flying in space that is observing the largest black hole in the universe is exciting to you, you should check out this interview that I did with Jeff Nosanov. And look forward to many more NIAC interviews. All right, we'll see you next time.